we start with viscosity. But before we delve into viscosity, we will study two things. One is a laminar or streamline flow, and another thing is turbulent flow. Now, what are these two things? The first, the flow of fluids is of two types. What? The flow of fluids. When a fluid is flowing, as you all know, is liquid and gas. So the flow of fluid, when they are flowing, there are two types of flows. One is named as laminar or streamline flow, also known as the steady flow. Number two is the turbulent flow. Now, by definition, what is number one? Number one means laminar or streamline flow. What is it? A smooth and uninterrupted flow in ordered layers. Layers means like this. If we consider these layers, then we can say that there is a smooth and uninterrupted flow in ordered layers. Ordered means layers cannot be like this, one here, one here, one here, one here, not this one. This is known as the ordered layers. Without any energy transfer between the layers, there is no energy transfer between these two layers. It's called laminar flow, streamline, or steady flow. Any one of these names can be applied. Now, if we try to understand in a bit of explicit manner or elaborate manner, we can say the velocity of a fluid along its flow in general depends on position and time. We can say V is a function of x and t. I repeat, velocity of a fluid along its flow, along the direction of flow in general depends on its position x and time t. This means that the fluid velocity may be different at different points, and at any particular point it may also change with time. That means there are two variants, one is the position and one is the time. So any one component varying means the velocity will vary. Now, mathematically speaking, for one dimensional fluid, that means the fluid flowing in one direction along the x direction. Now suppose this is the x direction. The fluid velocity is a function of fxt. That means velocity is a function of fxt. But for a laminar flow, or streamline motion, the fluid satisfies the condition that v is a function of x only. That means v must be a function of x only. This is the difference between ordinary flow and the laminar flow. Laminar flow means v is equal to f is a function, velocity is a function of only position. Okay, for a laminar or streamline motion, the fluid satisfies this relation. It means at any particular point along the flow, that means at any particular point, this is the point, any particular point, this can be a straight line, this can be a curved line also, any point, at any particular point along the fluid flow, the magnitude and direction of the fluid velocity do not change with time, although the velocity may be different at different points. That means it is a function of displacement. So you can write it's a function of displacement but not a function of time. So these two things describes laminar flow. In layman language or in a very simple language, we can say that if this is a streamline layer, this is a streamline layer, I've already said there will be no energy transfer between these layers. If we take this point, the velocity of a particle along this direction, let it be VA. This point is VA. This point is A. So velocity along the direction will be A. Now another point B, another point C. Direction will be like this. Now when we say that this is a laminar flow, the condition that has to be satisfied is the velocity of the particles flowing through these points will have the same velocity as their preceding particles. That means one particle has flowed, this has got a velocity. Velocity means the vector quantity. We have got a position, we have got a magnitude and direction. That means the particle following it must have same magnitude and direction as that of the previous particle. This is known as laminar flow. Now, two things or we can say properties How many properties? I can name how many properties? Two properties. Number one, we can say that two streamlines never intersect each other. If you have studied lines of force in magnetic field or electric field or electrostatic field in class 10, then you will find what we mean by line of force. The same concept applies here. In that case also we had learnt that no two lines of force intersect each other. Here also two streamlines never intersect each other, because if two streamlines actually intersected, if they intersected, that means at this particular point there will be two directions of velocity, which is practically not possible. There will be two directions of velocity at the intersecting point, so this is not practically possible. Now the second point we can write that when the streamlines are crowded together, I can write when streamlines are crowded together, what happens if we see that streamlines are crowded together? We can say velocity is higher. That means velocity is of a higher magnitude, and speed is low, and vice versa. I am writing and vice versa. That means if they are not crowded, there is plenty of space between the two lines, then you can say the velocity is smaller. The second type of flow is known as the turbulent flow. As I have already written here the definition of turbulent flow. You first look at the diagram. Turbulent flow means every particle will move in a complete haphazard manner. There is no rule, no law. If the velocity of a fluid along its flow continuously and randomly, this word is the most important word, randomly, random motion, no rule, no law, changes in magnitude and direction, then it is called a turbulent or disorderly flow. After this, we will start with the concept of viscosity. So we start with the concept of viscosity. Now, the first thing that you have to keep in mind that this description or explanation belongs to laminar flow and not turbulent flow. Only thing you have to keep in mind that this is the case for streamline motion. So when a liquid is flowing, when a liquid flows slowly over a fixed horizontal surface, suppose this is the solid rigid horizontal surface or the fixed horizontal surface, you can take it to be the bed of the river, bed of the sea, anything you like. For a laminar flow, why laminar flow? Because you see that I have divided it into layers. So layer flowing means it is a streamline motion or a laminar flow. The layer of the liquid in contact with the fixed surface remains at rest due to adhesion. Now this is the layer in contact with the fixed surface, almost remains at rest. If the profile or the distance of the top layer is more from the solid rigid horizontal surface, you will find that this particle will remain at its initial position after 1 second, 2 seconds, 3 seconds. It will not change, so it will remain at rest. So for a laminar flow, the layer of the liquid in contact with the fixed surface remains at rest due to adhesion. You all know what is adhesion. It is the force of attraction between two different kinds of molecules. Cohesion is the force between two same types of molecules, where addition is the force between two different types of molecules. So the layer just above it, this is the last layer, the layer just above it, it moves slowly over the lower one. Now that layer just above it, it moves a little bit faster. So the velocities of the liquid layers increases with the increase in distance from the horizontal surface. Whenever we will discuss this thing, we will state in this way that the distance of the layer, the more is the distance of the layer from the fixed surface, more is the velocity of that layer. But from the top we can say that more is the depth, lesser is the velocity of the layer. So the upper layer tends to accelerate the lower layer, while the lower layer tends to retard the upper one. So the upper layer, I have written in this way, but actually it means that upper layer accelerates and the lower layer recedes backwards. So upper layer tends to accelerate the lower layer, while the lower layer tends to retard the upper one. Therefore, two adjacent layers tends to decrease the relative velocities, as if a tangential force acts on an upper layer and tries to oppose its motion. That means a tangential force is acting on the upper layer. If we take these two layers into consideration, a tangential force is acting on this layer, which is helping this layer to accelerate. Now, if this layer accelerates, this layer just below it will move in the opposite direction, or we can say the velocity will decrease. So after this we can say that to maintain a constant relative motion, we have said that relative motion or relative velocities, to maintain a constant relative motion between the layers, an external force must act. An external force must act. If there is no external force, then there will be no relative motion, then the relative motion between the layers will cease, no relative motion, and the flow of liquid will stop. The flow of liquid will stop. This is a very vital statement. The liquid flows, we can say that it is complementary to each other, the liquid flowing and the viscosity acting. If there is no viscosity, if there is no external force, the layer motion or the motion of the layers of the liquid will stop. So by definition we can say the property by virtue of which a liquid opposes the relative motion between its layers, I repeat, property by virtue of which a liquid opposes the relative motion between its layers is called the viscosity of the liquid. So viscosity we can say is a kind of friction. We have studied about friction between two solid surfaces. Here we are going to study friction between a solid surface and a fluid or liquid. Now, if a question comes that you have to compare viscosity with friction, what we may say? Question is, compare viscosity with friction. Now the answer will be, viscosity is a general property of the fluid, as we have all studied. The frictional force between two solid surfaces, remember, frictional force between two solid surfaces resembles in many ways the viscosity of a liquid. So viscosity can be termed as an internal friction. Viscosity termed as internal friction because this friction occurs between the layers of liquid. So this is termed as internal friction of a liquid. Now, like friction, the viscous force is absent if a liquid is at rest. When a liquid is flowing, there is viscosity. If the liquid is at rest, there is no viscosity. The difference between these two, that is the frictional force in solids and the frictional force in liquid, is that the viscous force depends on the area, while the frictional force between solids does not depend on the area. That means we have already studied for solids, frictional force is proportional to the reaction force. Frictional force, this was the pull, the reaction force R, frictional force F, P was the pulling force. But for viscosity, that means two solids, between one is a solid and one is a liquid or a fluid. Here it depends on the area, depends on the area of contact. But this one, the friction between two solid surfaces like this, they do not depend on the area of contact. Now another question, you can say compare the mobility of suppose alcohol, and you can take oil, any kind of oil. We all know the viscosity of oil is more. That means viscosities of different liquids are different. So alcohol and oil do not have the same viscosities. If alcohol and oil are poured separately into two identical vessels and stirred, then oil will come to rest more quickly or earlier. This shows that the viscosity of oil is greater. When we stir it, the round motion or the circular motion will come to a halt for oil more earlier than alcohol. Greater is the viscosity of the liquid, lesser the mobility of the liquid. So we can write greater for answer. We can write greater the viscosity of a liquid, lesser the mobility. And if you remember this point, you can answer questions of this sort. Now, velocity profile. Another most very important term is velocity profile. What do you mean by velocity profile? Now I can draw one or two diagrams like this. These are the positions of the particles. They are flowing in this way. So you can say this plane as the velocity profile. But if you take a tube, water is flowing through a tube. That means the velocity of water at the velocity of the layer of water just at the middle, just at the center will be the maximum, and as you approach the body of the tube, the velocity will slowly decrease. So the velocity profile will look like this sort of parabolic form. So these are known as the velocity profile. Now what happens to a velocity profile of a non-viscous fluid? Non-viscous fluid you can term non-viscous or ideal fluid. Ideal fluid is non-viscous. The property of non-viscous or non-viscosity is applicable for ideal fluids. For such a liquid, there is no resistance due to viscosity. The velocities of the different layers are the same. They are the same. Every particle in a given cross section of the liquid. That means you take a pipe, take two layers. Let this be one cross section. So every particle in this cross section of the liquid moves forward with the same velocity. There will be no shifting of the velocities as we had seen earlier. On joining the ends of these velocity vectors, we get a plane surface like this one. Therefore, we say that the velocity profile of a non-viscous liquid is linear. So we can say this one is for a viscous fluid, this one is for non-viscous fluid. So I can write this one as non-viscous or ideal, and this one as viscous liquid. Now we start with the coefficient of viscosity. This is a solid horizontal surface PQ. Now a liquid is in streamline. First of all, you have to take, I have already told this thing, streamline motion. A liquid is in streamline motion over the surface PQ. A liquid is flowing. Now the liquid surfaces, we take two liquid surfaces like this. One, let us name it Mn, and another we name it CD. So these are the two liquid surfaces CD and Mn. The distances of x from the fixed surface, and the difference between these two layers, let it be dx, small. So the distance of CD from PQ is x, and distance of Mn from PQ is x plus dx. Now the velocity of the layer CD, this is the layer CD. The velocity of the layer CD, suppose it be v, and the velocity of this layer is v plus dv. Now due to viscosity of the liquid, an opposing force acts between these two layers. One tries to move forward, another tries to move backward. This tries to slow down the relative motion of the layers, as I've already stated. If this opposing viscous force is F, so we take the viscous force to be equal to F. Then for streamline motion of the liquid, I repeat, then for I write it, then for streamline motion of liquid, a rule was formulated, and no other than Newton. Newton proved that number one, this viscous force was proportional to area. I have discussed this point, that is the area of cross section, where A is the area of cross section of liquid surface. Number two, F is proportional to dV dx. Now what is dV dx? Dx means this portion, dV is the change of velocity. So for a shift of a distance dx, there is a shift of for a shift of a distance dx, the shift of velocity or the magnitude of velocity is dV. That means the velocity has increased by dV. Distance dx has increased, as well as velocity magnitude has increased by dV. So F proportional to dV dx. Now this dV dx is known as the velocity gradient. In one single term, they have termed it as velocity gradient, or in a lengthy format you can say the rate of change of velocity with distance. Rate of change of velocity with change of distance from the solid surface. So combining these two, according to the law of joint variation, we can say A dV dx proportional. So we can constant. Now this constant is written as in this form. This is known as eta, ETA. So eta is a constant known as the coefficient of viscosity. This is named as eta, and here we take it to be the coefficient of viscosity. Now we can get eta is equal to F by A dV dx. Now if A is equal to 1, if A is equal to 1 and dV dx is equal to 1, then eta is equal to F. So from this we can define the coefficient of viscosity. We can define the coefficient of viscosity. So we can tell the coefficient of viscosity of liquid is defined as the required tangential force acting per unit area to maintain unit velocity gradient between two liquid layers unit distance apart, because dV dx means 1 means 1 by 1. That means change of velocity is unity, change of distance is also unity. I repeat the definition. The coefficient of viscosity of a liquid is defined as the required tangential force acting per unit area to maintain unit velocity gradient between two liquid layers unit distance apart. Unit of viscosity, SI unit, we can write it in this way. We have F by A dV dx. So F is Newton, area of cross section is meter square, dV is meter per second, and dx is meter. So this meter and this meter gets cancelled, second goes above, Newton second per meter square, or Newton second meter minus 2. Now you can write this also in the form of Pascal second, because Newton per meter square means the pressure or stress, that is Pascal second. Another form we can write that Newton, if we write as kg meter per second, kg meter per second, uh, sorry, second square, I suppose, yes, into second meter square, inverse square, we can get this to be equal to kg meter minus 2 meter minus 1 second minus 1. So this, there are three types of units you can write. Similarly, for CGS format, we can change the CGS forms of this, that is dyne second centimeter inverse square. We can write we cannot write this one, we can write this one, gram centimeter inverse second inverse. This is also one unit of viscosity. This is one unit of viscosity. Now, definition of poise is the coefficient of viscosity of a liquid is 1 poise when a tangential force of 1 dyne is necessary to maintain a relative velocity of 1 centimeter per second. That means the CGS unit can be poise. I repeat, the coefficient of viscosity of a liquid is 1 poise when the tangential force is 1 dyne that is necessary to maintain a relative velocity of 1 centimeter per second between two layers of the liquid 1 centimeter apart, where each layer has an area of 1 centimeter square. So this is the CGS unit of viscosity, coefficient of viscosity, sorry. So 1 poise we can write like this, 1 dyne second centimeter inverse square, or 1 gram centimeter inverse second inverse, as I've already stated. Now the relation 1 kg meter inverse second inverse, that is the SI unit, is equal to 10 g centimeter inverse second inverse. If you replace kg by if we convert kg to gram, that means multiply this with 1000, meter inverse, meter comes down, so 100 centimeters and second remains as usual. We see that the relation is 10. It's the multiplying factor is 10. So we can write 10 poise because 1 gram per centimeter per second gives 1 poise. So 10 means 10 poise. And the SI unit can be termed as decapoise. POISE, DECA, POISE, decapoise. That means that must be equal to 10 poise. So the coefficient of a liquid is 1 decapoise. 1 decapoise when a tangential force of 1 Newton is necessary to maintain relative velocity of 1 meter per second between the parallel layers separated by distance of 1 meter, where the layer has an area of 1 meter square. Just we have transformed everything into the SI system. Another one we can say the dimension of viscosity. This is also very easy. So eta is equal to F by A dV dx. Just replace F dx by A dV. So what is force? That is ml t minus 2. What is dx is a kind of distance. A is L square and this one is L t minus 1. So if we L minus 1 square 1 2 L, L 1 L remains, so t minus 1. So this is the dimension of viscosity. Now two very important things, that is pressure and temperature. These are the two parameters to handle, or we can say the effect of pressure and temperature on the coefficient of viscosity. So we can write effect of pressure on viscosity. What is the effect of pressure? Usually viscosity increases with pressure. Viscosity increases with pressure. Viscosity increases with pressure. In less viscous liquids, the viscosity increases at a lower rate with pressure. It increases, but increases at a lower rate. For what? For less viscous liquids. Now, but for highly viscous liquids, increase in pressure results in a rapid rise in viscosity. Now, for water, it's a case where water behaves differently. Like with an increase in pressure, its viscosity decreases, reverse. Now, exception to this rule, that rule means viscosity increases with pressure. Exception is water. Exception is water, where exception is viscosity decreases with pressure, with the increase of pressure. That means viscosity decreases with increase of pressure. Now, effect of temperature. Effect of temperature on viscosity. If you write, you can write a relation like this: eta T is equal to A by 1 plus Bt to the power C. Now, we all know eta T is the viscosity of a liquid at T degree centigrade. Eta T is viscosity of liquid at T degree centigrade. Any liquid, viscosity of any liquid at T. Now, A, B, C are all constants. Now, I can say, what we can say, that coefficient of viscosity decreases with the rise in temperature. So, coefficient of viscosity, what happens? Coefficient of viscosity decreases with rise in temperature, because the temperature factor is in the denominator. So as temperature increases, viscosity will decrease. It's a inverse form. But for gases, you must remember this point. For gases, the coefficient of viscosity increases with increase in temperature. But for gases, it increases, it means viscosity increases with increase in temperature, or rise in temperature, as you may say it, in temperature.